Hello guys, welcome on Tesla Adventures. In this video today we are going to discuss some concept illustration problems for Pascal's law. You know that in the previous video we discussed about the Pascal's law, and in this video we are going to discuss some problem, in fact three problems which would correctly demonstrate how to apply the Pascal's law. So I call these problems as concept illustration problem due to the fact that they are very helpful to illustrate and demonstrate the concept which we have already studied. So let us start with this first problem. You can see that there is a container in which some liquid is filled, and this container is kept on a rough inclined plane, and the friction is sufficient enough so that this container is not sliding on the inclined plane. So this container is kept at rest on this inclined plane, and we have to find out the difference of pressure at B and A in terms of the variables which are mentioned in this screen. So the variables which are given is only rho, this is B, and this is theta. So by using these three variables, we have to write down the difference of pressure between B and A. So first of all, we know that we have studied that the definition of fluid is that fluids are the materials which does not which does not resist the tangential force, which means that if some tangential force is applied on the fluid, then they will start to flow. But obviously this fluid cannot flow because it is filled in this container, and the net force acting in this position on this fluid is mg, which is vertically downwards. So the free surface of this liquid will align itself so that the net force is not tangential and it is perpendicular to the free surface, so that no component of this force is parallel to this free surface. And if any component is parallel to the free surface, then the free surface will flow, but it cannot flow. So the free surface will align itself in such a way such that it is always perpendicular to the net force acting on the fluid. So this is the level of the fluid which is parallel to the horizontal level. And now we have to find out this difference of pressure. So to find out that difference, let us assume that this is this length, this height is h2, and this is h1. So we can say that, and this height, this one is let's suppose L2, and this height is L1. Okay, this one. Now I can say that the pressure at the surface is P naught, and pressure at B will be equal to P naught plus L2 rho g, and pressure at A will be equal to P naught plus L1 rho g. And you can see that P naught is the common factor, rho g is the common factor, and L2 is greater than L1. So we can say that PB will be greater than PA, and therefore the difference of pressure will be PB minus PA. So PB minus PA will be L2 minus L1 into rho g. This is PB minus PA, and this difference of pressure can be written in terms of H2 and H1 also, because you can see that if this angle is theta, this angle will be 90 minus theta, and this will be theta. So I can say that L2 will be equal to H2 cos theta, and L1 will be equal to H1 cos theta. Okay, so H2 minus L2 minus L1 will be PB. In fact, this would be PB minus PA will be equal to H2 minus H1 into cos theta into rho g. Okay, so this is H2 minus H1. Now if we find out if you redraw this diagram, we can say that let us draw the diagram again. If this is the container, if this is the one second, yeah, this is the container and the liquid level is like that, okay, and that this angle is theta, and this is h2 minus h1, and this is b. So we can say that tan theta is equal to h2 minus h1 upon b. So h2 minus h1 is b tan theta. So pb minus pa is equal to b tan theta cos theta rho g. So tan theta is sine upon cos, so this will be b sine theta rho g. So this will be the difference of pressure between B and A. Now let us move on the next question. In this question you can see that a circular tube is filled with two different liquids equal in volume. So you can see that this liquid is filled in the volume which is equal to the volume of this liquid, and the angle subtended by this liquid at this center is 90 degree, as well as the angle subtended by this liquid is also 90 degree, and they are combinedly subtending an angle of 180 degree at the center. But obviously, as the value of densities is not equal, so this line, which is the line connecting the free surfaces of the two liquids, will remain horizontal, and the theta will be 0 if densities are equal. But in this case, densities are not equal, and in fact rho 1 is greater than rho 2. So obviously this liquid will be at some lower level. So we have to find out the value of theta in equilibrium, obviously. So you can do this question in two ways. So let us discuss the method 1 in brief detail, because you have to attempt this method. I'll just demonstrate how. So you, in the first method, by using the Pascal law, you can assume these points A, B, C and D. So pressure at A, and you can assume that pressure inside this empty tube is pressure of air, and it is P0. So let us assume that PA is P0, and obviously PD will be equal to P0. Okay. Now if this height, which can be calculated, this is the height till C, this height is h1, and this height till B is h2, and this height from C to B is h3. So what you will do, you will write down the pressure at C as h1 rho 1g plus P0, which is the pressure at D, and you will write down the pressure at C from this side, and it would be h2, in fact first of all P0 plus h2 rho 2g plus h3 this height. Now in fact this is the liquid rho 1, so this will be h3 rho 1g, and h3 and h2 and h1 can be calculated by angles and assuming the radius to be r. So by writing this equation, by equating this equation, you can easily find out the pressure. You can write down the pressure at C, and you can compare, and you can find out the angle theta. So this method you have to try, and I will be discussing a smart and a easy method in this case. So in this case, let us discuss another method, which is the method of torque. So let us see that that obviously the center of mass of this liquid will be somewhere on the angle bisector line, and this is 45 degree. So somewhere at this point, at a distance of r from the center, let us assume that the center of mass is situated C1, and mg would be acting in the downward direction. like that, m1g. And in the same way, the center of mass of this liquid will be also on the angle bisector line. This is 45 and again this is 45. So this angle is 45 minus theta, and this complete angle is 45 plus theta. And again its center of mass will be at this point at a distance of r from the center. I do not need to know the value of r because it would cancel out. So this is m2g. Okay, so now we know that if this liquid is in equilibrium, then we can say that net torque about center will be 0, about this point O. So while writing the equation of torque, we can say that torque would be mg into this distance. Now let us see that this will be the distance, let's suppose L1, and the distance of this will be L2. So the value of L1 will be, you can see that this is R and this is 45 plus theta, so it would be R cos 45 plus theta, R cos 45 plus theta, and the value of L2 will be R cos 45 minus theta. This is 45 minus theta, so L2 will be R cos 45 minus theta. So the torque will be m1g into L1 and the torque of m1g, and it would be equal to the torque of m2g, which is m2g into L2. Cancelling g with g. So you can write down the value of mass as volume into density, and volume is equal. So let us assume that the volume of each liquid is V. So m1 will be V into rho1 and L1 will be R cos 45. In fact, I'll write it down here. So m1 is V into rho1 and L1 is equal to R cos 45 plus theta, and m2 is V into rho2 and L2 is R cos 45 minus theta. Cancelling V with V, R with R, rho1 by rho2. Let us use the next page. Rho1 by rho2 is equal to, this is cos 45 minus theta upon cos 45 plus theta. Cos 45 minus theta upon cos 45 plus theta. So this will be, by opening it with the cos A minus B and cos A plus B formula, this would be cos theta plus sin theta divided by cos theta minus sin theta. And this will be taking cos theta common. This will be 1 plus tan theta upon 1 minus tan theta. So by calculating it, by solving it, you can see that tan theta will be equal to rho1 minus rho2 divided by rho1 plus rho2, and theta will be equal to tan inverse rho1 minus rho2 upon rho1 plus rho2. This will be the correct answer. Now let us move on the next question. In this question, you can see that this is a tube which is bended at 2 points, and this is the open end of the tube and this is also the open end, while these are the closed ends. And it is given that liquid is not coming out from these open ends. It is in equilibrium and the liquid filled in these 3 tubes is different. This is rho1, this is rho2 and this is rho3. So we have to establish a relationship between rho1, rho2 and rho3 in such a way such that liquid will not come out from these open ends. So let us assume that this height is h, and due to the fact that we are assuming this variable, so it should not appear in the final answer. So let us see that, let us suppose that this is point A, this is point B, this is point C, and this is point D. And obviously, as this is the open end, the pressure just above this tube will be P naught, and therefore the pressure at A will be P naught. And obviously at this end, pressure at D will be P naught. See, liquid is not coming out from this tube due to the fact that pressure at D is balanced by pressure of atmosphere, which is P naught. I'll be demonstrating one example which you can practically demonstrate at your home in the later part of this video. So pressure at D will be also equal to P naught. Now pressure at B can be, I'll write down the pressure at B. So pressure at B will be pressure at A plus H rho 1 G, because point B is below the point A, so the pressure at point B will be greater than point A. So pressure at point B will be PA plus H rho 1 G, and as we know that PA is P naught, so let us write it down as P naught directly. And in the same way, point D is vertically below the point C by a height of H, which is same. So pressure at D, which is P naught, is equal to pressure at C plus H rho 3 G. Okay, and now we know that to establish the relationship between C and B, we know that B point is just below the point C. So pressure at B will be equal to pressure at C plus H rho 2 G. Now pressure at B is P naught plus H rho 1 G, and pressure at C is P naught minus H rho 3 G. You can extract the pressure at C from this equation. So cancelling, in fact, plus this term would be there, H rho 2 G. So plus H rho 2 G. So cancelling P naught with P naught and HG is cancelled out. So rho 1 will be equal to rho 2 minus rho 3. This will be the final relationship between these densities. Now let us discuss one example which you can perform at your home. You can take a Bisleri bottle, disposable water bottle, and you can seal the cap of that bottle to a airtight extent. You will be filling this bottle completely, and you will be sealing the top. Now there is a hole in the bottom of the bottle which you have sealed by your thumb, but as soon as you will remove the thumb, the water will start to come out. But you will see that eventually, by descending down some height, the water will stop to come out. Even though the hole is open, water will not be coming out of the hole. So it means it happened due to the fact that when this liquid was completely filled, there was no air, and as the cap is airtight, air cannot enter this vessel. So when this liquid will descend, the empty space will have zero pressure. So the pressure, if this height at which the liquid ceased to come out, if this height is H, we can say that the pressure at this point, which is just inside this container above this hole, is P0. This is pressure will be 0. So 0 plus H rho G, and the pressure at this point, which is just outside, will be P naught. And these two will be equal because liquid is not coming out. Therefore, if these pressures are equal, therefore liquid will not come out of the bottle. But as soon as you will slightly open this cap, air will enter, and the pressure at this point will be P naught. and the pressure at this point, which is just inside the container above the hole, will be P naught plus H rho g, which would be definitely greater than the pressure at this point, because the pressure at this point will be P naught only. So due to the additional pressure of H rho g at this point, the liquid will start to come out from the bottle. Okay, so this experiment you can demonstrate at your home, and you can name this experiment as magic to your younger brothers and sisters. Okay, I used to do this to my sisters and brothers which are younger than me. So this was the complete concept illustration problems, and in the next video we'll be discussing some advanced applications of Pascal's law. Thank you.